Assalamualaikum sir. So today we will present about assignment 3. My name is Nabisha. For assignment 3, the introduction for this assignment. The assignment 3 is given by my lecturer, is Dr. Falah, to make a report basically based on chapter 1, 3, 6 and 7. The course outcomes is we will know about how computer hardware and software work together, the motherboards, understanding and installing hard drives, multimedia devices, and mass storage. We try our best to complete this assignment. In addition, in completing the assignment, we will definitely get a lot of benefits and we use the information in our daily life, especially everything that are related to PC. So question part A, question 1, explain briefly how operating system manage computer hardware. Operating system manage the computer's memories and processors as well as its software and hardware. The operating system provides a comprehensive platform that identifies, configures, and manages a range of hardware, including processors, memory devices, and memory management, chipset storage, networking, and port communication. Most of the time, your computer operating system has several different programs running at the same time, and they all need to access your computer's central processing unit, memory, and storage. An operating system can also support APIs that enable applications to utilize operating system and hardware functions without the need to know anything about the low-level operating system or hardware stack. For this, the three main common operating system for personal computers are Microsoft Windows, Mac operating system, and Linux. Every operating system requires UI. There are two primary types of UI available, which is CLI and GUI. A GUI lets you use your mouse to click icons, buttons, and menus, and everything is clearly displayed on the screen using a combination of graphics and text. The best interface where users rely on the traditional keyboard to enter specific commands, parameters, and arguments related to specific tasks. Okay, next question I will pass to my member.
Okay, so hello sir, my name is Sarah and I will be presenting for question number 2. So the question number 2 is, when you turn on the power to a PC, CPU begins to boot by initializing itself and then turning to the ROM BIOS for instruction. Sort out the steps involved in this process. So we have 5 steps, which is the first step is power up. So the first step of any boot process is applying power to the machine. When the user turns a computer on, a series of events begins that ends when the operating system gets control from the boot process and the user is free to work. When the computer is turned on, the central processor executes some startup code in ROM that is located on the motherboard. So for step number 2 is power on self-test. The next step is called the POST, P-O-S-T, which is power on self-test. This test checks all connected hardware, including RAM and secondary storage devices to be sure it is all functioning properly. After POST has completed its job, the boot process searches the boot device list for a device with a BIOS on it. So move to step 3, find a boot device. The I/O system is essential to the operation of the computer because it defines the rules for communication between the CPU and the other device attached to the computer via the motherboard. The I/O system, sometimes found in the IOCs file on the boot device, provide extensions to the BIOS located in ROM on the motherboard. So next step is step 4, which is load the operating system. Once the hardware functionality is confirmed and the input-output system is loaded, the boot process begins loading the operating system from the boot device. The OS is loaded into RAM and any instructions specific to the particular operating system are executed. The actual operating system is somewhat irrelevant as the computer will follow the same boot pattern in any case. So move to the last step, which is step 5, transfer control. Once the previous steps are complete and the operating system is safely loaded into RAM, the boot process relinquishes on control to the OS. The OS then proceeds to execute any pre-configured startup routines to define user configuration or application execution. At the end of the handoff, the computer is ready for use. So that's all from me. Pass to the next member. Thank you.
Hello, sir. My name is Evelyn. I will present the question 3 is about 5 RQ number. First RQ number is RQ0. RQ0, the typical use is system time. This interpret is reserved for the internal system time, TITS, may be one short or predict. One short time will signal only once and then stop counting. Predict timers signal every time they receive a specific value and then restart, thus producing a signal at predict intervals. RQ1, the typical use is keyboard. This interpret is reserved for the keyboard controller. Even one device without a keyboard, this interpret is exclusive for keyboard input. Vital keyboard one on touchscreen have no physical switch and provide audio and haptic feedback insert. RQ2, the typical use is cascaded interpret for RRQS 8 to 15. This interpret cascaded the second interpret controller to first. RQ3, the typical use is second series port, COM2. The interpret for the second series port and often the default interpret for the fourth serial port, COM4. RQ4 type typical use is the first series port, COM1. This interpret is normally used for the first series port. One on device that do not use PS2 mouse. This interpret is almost always used by the serious mouse. RQ5, the typical use is the sound card. This interpret is the first choice, the most sound card made when looking for an RQ setting. Thank you.
Okay, hello sir. My name is Wilfred Wong, and I will be explaining the 5 questions before selecting a motherboard. The first question is, what is the use of the PC that you're getting? As such, in what is the motherboard purpose? If your workload is not too heavy, examples such as just only by typing or just doing like light recording, it doesn't require someone or the user to buy a really high-end or powerful motherboard. But if your case is such as making or rendering heavy videos, which needs or requires a very high processing power, the motherboard needs to be quite high-end. So by getting a higher end motherboard, you can accomplish those high processing tasks. The second question is, what is the form factor? In my answer, the form factor is related to the size, but we know that form factor is also related to the processing power. But in my case, the users can also choose between, do you want a bigger motherboard or do you want a smaller motherboard? It all suits in between the layout of the setup in your computer. If you choose like a bigger size casing for your computer, you can choose from the ITX models. But if you want a smaller one, which is a bit more pricey, but it's small, so it can fit into multiple places, you can go all the way to the mini ITX. Bigger size also comes with more attachments, and you can also upgrade in the future. But smaller one, there's some disadvantage and its own advantages. For the third questions, what is the CPU socket? As we all know that CPU sockets comes in a lot of various models, different types. Like the main type is from Intel and AMD. From the Intel, we know that it's in a very long lasting companies, as this company provides wide ranges of really trusty processors, all the way from the LGA 1150 or from i3 all the way to i7. But and also another company is also the AMD sockets. AMD is more to a cheaper side of the budget range of the PC. So choose wisely. Do you want performance, budget, or both? The next question is, after you picking the CPU socket, what will you choose as the chipset? Since chipsets is also quite important, which determines what model of CPU do you want. If the model of the CPU doesn't match with the model of your motherboard, you will not be able to place that CPU inside the motherboard. So you have to really pick carefully first on what kind of CPU do you want. If the CPU is a very high-end CPU, it might not support most of the current motherboard. But if you pick a lower-end CPU, it might be able to fit in most current motherboards. So also chipsets also allows integrated graphics. So we need to think carefully first. So choose wisely in what the chipset is. And the last question is, what is the RAM required, or what do you want your RAM to be? As is related also to the first question. If you think that your CPU, your computer needs really high processing power, you can go for a higher RAM. Example, like if you have a full gaming setup with streaming capabilities, you will need a very high RAM usage. With a really high RAM usage, you also need a motherboard that can support what you are doing. If the motherboard have multiple RAM slots, it's very good for what you are doing on high end purposes. But if you buy such a powerful motherboard just only for doing like typing or maybe communicating on social media, it's actually a waste. So to accommodate that, uh, buying a lower RAM model CPU a motherboard is also recommended in this case. Also, in this RAM part, not all motherboard can support all RAMs. So you must make sure that the amount of RAM that you're buying is in the limit of your motherboard. If a RAM is at 32 gig, but your motherboard doesn't support a 32 gig RAM, it's also a fatal mistake to the user, because the user need to repurchase a higher end motherboard just to cope for higher gig RAM. So please check before this. So in conclusion of this, these are the 5 questions that I would state as my answer. So thank you, and I will move to the next member.
Hello, sir. My name is Noalia Atira. So for question 5, we have two questions in it. Okay, so for the first question is technology used within the hard drive to read and write data to the drive. Okay, so as the in the picture shown, okay, number 1 is actuator. It moves the read right arm. In older hard drives, actuator were staple motors. In the most modern hard drives, voice cores are used instead. Okay, number 2 is read right arm. It swings read right, head back, and forward across platter. Number 3, central spindle. It allows platter to rotate at high speed. For number 4, the magnetic platter. It stores information in binary form. Number 5 is read-write head. It is a tiny magnet on the end of the read-write arm. For number 6, it is a circuit board. It controls the flow of data to and from the platter. Number 7, flexible connector. It carries data from circuit board to read-write head and platter. Number 8 is spindle. The small spindle here allows read right arm to swing across platter. And lastly, the number 9, it is a plug connections. It links the hard drive to circuit board in personal computer. Move to next slide. For question number 2 is the technology used by the hard drive to interface with the system. Okay, there are 5 types of hard disk interface. First is IDE, second SATA, third SCSI, next SAS, and fiber channel. As in the picture shown, EIDE is an extension of IDE, means Integrated Device Electronics. IDE is also called as ATA, which is Advanced Technology Attachment. It is an early drive controller interface that connects computer and hard disk drive with a 40-pin connector. I think that's all from me. I will pass to the next member. Thank you.
Part B. You have been asked to set up, configure the network, purchase all the hardware and software. For the organization, your purpose should be complete. The setup. Small office networking is somewhat distant for the computing environment that service this organization. We are also referred to as business networks. Enterprise networks will have thousands of users and a diverse collection of service mainframe system, web area network connection, and the components. A business network contains a vast infrastructure that requires the attention of highly qualified network administrators. More moderate computer and network standards are needed for small organizations. You may have about a dozen computers and a couple of laser printers. The small office network must allow the representative of the company, printers, and other parties to exchange information. Most small companies have one or two LAN service using of-set components that can satisfy their computing requirements. Configure the network. Network configuration is the process of assigning network settings, policies, flows, and control. In a virtual network, it's easy to make network configuration change because physically network device applications are replaced by software, removing the need for extensive manual configuration. Service of managing files. Almost of computing system needs data storage. The main storage unit is in a standalone computer is the local hard disk. A service should be set up on the network to store data in such a manner that it can be shared by everyone in the enterprise. The network computer that specialists in offering shared data storage are known as file service. A network administrator can set up and monitor access to a number of shared folders using the built into the file service network operating system. Each customer will usually have their own private folder on the file service. Any other network user would not be able to see the data contained in the folder. I will pass the next person. Thank you.
Hi sir, my name is Nurfara Udina. For network sizing, get a good estimate of the project scale of the network, taking into account the number of users and the speed of which they use it. Be sure to prepare for potential development by adding a lot of additional space from the start. Determine how much power you will need in 2 or 3 years. Consider the increase in the number of new users as well as the drastic increase in data capacity requirements per device. Your network should be designed in such a way that it will quickly expand with gradually extension of existing technology. Choosing the network operating system. The selection of a network operating system is one of the most critical architecture challenge for any enterprise. This decision will have an impact on the low-level network protocols you use, how servers are managed, and how users communicate with network resources. The network operating system determines the overall appearance and feel of the network world. The network operating system is the program that operates on servers and specifies how network services are exchanged. Purchasing equipment. First, for a functional modem, depending on the ISP, internet service provider you choose, many of them do provide modems to clients once they sign with them. It is possible to get your own modem and have it installed within your network. A modem is a device that provides bidirectional communication between the ISP and the device connected to the network. Second, Ethernet cables. Depending on the size of the network and office, you will need substantial amount of Ethernet cables to effectively connect all the office devices in the network. Many modern network infrastructure usually tend to use either Cat5 or Cat6 cable. Next. Patch panel. These come in very handy in large networks since they make it much easier and relatively easier to connect a large number of network devices and computers. They normally contain a single Ethernet jack for every cable's termination. Patch panels have also been known to simplify the process of troubleshooting in case of any problems. Switch and router. Switch and routers and switching are key equipment in your business network as they are used to provide connectivity to multiple devices in the network. These devices normally connect to the modem using an Ethernet cable. It is worth nothing though that switch are the best suit for facilitating communication within a single office network. Thank you. Next member.
Conclusion. Hardware can be defined as the physical device and equipment of the computer that are required for the computer to start and function. Typical examples of hardware devices are keyboard, monitor, RAM, and processor. In essence, part of computer that can be seen physically can be treated as hardware. Software is the program that is required to operate the computer. Operating system is an instantial software required by the computer with access used to operate the computer. Without software, computer cannot be used. Hence, in conclusion, both hardware and software are vital for any computer system to work optimally. Thank you.
Thank you.
Thank you.
Thank you.
Thank you, sir.